Welcome to part 2 of binary search tree. In last lesson we looked at how to draw a binary tree. The first number is always going to be the root, and the root would have nothing on the left and nothing on the right, so it will have no child to start with. The next number, we'll check it against the root. 10 is less than 14, so it's going to go on the left. 28 is bigger than 14, so it's going to go on the right. And we keep doing this. Well, 6 is going to go on the left of 10. 11 is smaller than 10, so it's going to go on the right of 10. And 18 is bigger than 14, smaller than 28. And let's have another number, 31. So 31 is going to go on the right side of 28. So that's what we did last lesson. So that's a recap. In today's lesson, we're going to be looking at the pseudocode around how to insert into a binary search tree. So it's going to be a function because we're going to return a node at the end of our algorithm. The first thing we need to notice is that it is a recursive algorithm. So there's insert node value, insert node.left new value, insert node.right new value. There is a base case, and the first node that we insert in our binary search tree is actually going to be the root. And that's going to be whatever the value we want to put in. So let's say we want to put in the number 8. 8 is going to be our root. Now we're also going to be calling the algorithm, and when it reaches a base case, it will create a new node. So we're always going to create a new node, but the new node is going to be placed either on the right side or the left side of the parent. This part is when we compare the value of our node with its parent. So we check if the next node should go on the left. Now, if the value is smaller than the parent, then it would go on the left side. Now, insert node.left. Now, this node.left is going to be repeatedly called, returned as node.left. So node.left is going to be repeatedly called until it's a null. This part here, once it turns to null or known, it's going to now call the base. The base is going to return a new node. So this is where the new node is created. Remember, every time we create a new node, the new node would not have any children. So the left of it and the right of it is going to be null. Here it checks if, else if. Well, if it's not going to the left, then it's going to go to the right. So if the value of our new node is bigger than the parent, then it's going to go to the right side. Again, we're going to repeatedly call the recursive part of the algorithm until this node.right is null. And then we're going to end the if statement and return a node. We're now going to try to make a trace table to see how this algorithm would work. So we're going to try to insert the number 11, 6, 13, 4, 9, and 17. So if I want to insert 11, remember 11, step 1, there is no node in my tree. So there is nothing there. Because there's nothing there, there is no comparison. And in this case, the base case has been reached, which means we will create a node 11. This would be the root. This is very important. So that would be the root of our tree. Then we want to insert the number 6. Well, when I insert the number 6, I need to look at the current node, which is 11. So 6 is going to compare itself to 11. Well, 6 is smaller than 11. So it means that I need to place 6 on the left side. When I call the recursive algorithm again, step 2, it's going to see that the left side of 11 is null or known. If that happens, it means that we are creating, so we need to check if that's null or known. It means that it's empty. We can only insert if it's empty. So we will look at putting a new node 6 at the left side of our 11. So we would have 6 on the left side. Let's have a go at inserting the number 13. Now, when we insert number 13, step 1, our current node is going to be 11. Then we need to check, well, 13 is bigger than 11. So if 13 is bigger, it means we're going to the right side. On the right side of 11, it's actually null. There's nothing there. If there's nothing there, it means that we can insert our number 13 on the right side of 11. So that's how it works on the basics. Let's have a look at inserting the number 4. So I want to insert number 4. First, I compare it to 11. Well, 4 is smaller than 11, so go left. Then, well, I look at 11 and then the node to the left of 11 is 6. So now I need to compare 4 to 6. Well, 4 is smaller than 6, so I need to go to the left. But when I get to the left of 6, there is nothing there. Now, if there's nothing there, remember I need to keep calling my recursive algorithm until there's nothing. There is none on the left side. If that's the case, that is the only time I can now create a new node, node 4. So 4 goes on the left side of 6. We need to do the same for inserting 9. I want you to start thinking with me. So 11, well, 9 is smaller, so we're going to go to the left. Well, on the left of 11 is 6. We need to do the same thing. We need to compare 6 and 9. Well, 9 is bigger than 6, so we need to go right. Now, on the right side of 6 is null. Now, this is where the base case has been reached. In this case, we need to create our node, and our node will have a value 9. Let's look at inserting 17. So first we need to check. Well, 17 is bigger than 11, so we need to go to the right. Well, we need to now look at the right. Well, the right side of 11 is 13. We need to compare. Well, 17 is bigger than 13, so we need to go to the right. But wait a minute, when you get to the right of 13, it's null. There's nothing there. Now, when there's nothing there, that's the only time we could put a new node. So we are going to create a node 17 here. And that is our tree completed, following the algorithm. Your turn now. So pause the video. Have a go at a new tree where you have the number 15, 8 and 20. Right, check your work to see how far you've gone. So number 1, 15 is the root. When we look at 15 and compare it to 8, 8 is smaller, so we're going to the left. Well, We now need to create a new node and put that on the left of the number 15. We do the same for 20. Well, we compare 20 to 15. We're going to the right. On the right side of 15, there is nothing there, so we need to create a node 20 and place it on the right side of 15. Your turn now. Have a go at finishing the tree. So insert the number 4, 12, 16. Create your table. Pause the video. Right, let's see how you got on. So number 4. Now 4 will look like this. So we compare it to 15 and we compare it to 8. And then we create a node on the left side of 8. Number 12, compare it to 15, we compare it to 8, and then it's going to be placed on the right side of the number 8. And finally, we have the number 16. Okay. And that's what it will look like. Now, it might be a good idea to also draw the tree. I haven't actually drawn the tree, but you might want to actually draw the tree to see what it should look like. Okay, finally, let's practice some questions. So I would like you to think about the pseudocode, filling the missing lines in this pseudocode. Pause the video. If you have find the video helpful, please click the like button. Let's look at the answer now. Let's see how you got on. That is the answer for our missing lines in our pseudocode. Right, so the next part of the lesson is going to be looking at the actual codes, so the Python codes. What does that actually looks like? All right, see you soon.